Hello everyone, I am going to walk you through the solution for the question that is graded on assignment number 1. Okay, so here is the question that's graded. It's from section 1.2, number 12, and we're looking to identify whether the following system specifications are consistent. So the first thing we want to do is identify and assign variables to all of the propositions. So the first one is the file system is not locked. We'll change our color. Second one is new messages will be queued. So the file system is not locked again. So the system is functioning normally. And we have again, new messages are not queued. So that's the negation of this one, so it's not new. So new messages will be sent to the buffer image. So we need a new color. And then if the file system is not locked, then new messages will be sent to the message buffer. New messages will not be sent to the message buffer. Okay, so we have no new proposition. So now we just need to identify variables for each proposition. So let's say let L be the file system. Let's say is locked, and then we will negate that. Okay. The next one, new messages will be queued. So let's say let Q be new messages will be queued. And then the blue one, the system is functioning normally, so let N be the system is functioning normally. And finally, new messages will be sent to the message buffer. So let B be new messages will be sent to the message buffer. Okay, so now we need to translate each of the system specifications into logical propositions. All right, so let's pick a neutral color. So the following are the system specifications. Okay. If the file system is not locked, so that is not L. So if not L, then Q. Again, if the file system is not locked, so again, not L. If not L, then N. Then the system is functioning normally. Oh, and conversely. So that means that we have a biconditional operator, right? The converse of that is if the system is functioning normally, then the system is not locked. Okay, then we have if new messages are not queued. So Q was new messages will be queued. So we have if new messages will not be queued, then they will be sent to the message buffer. Then B. And if the system is not locked, so again, not L, then new messages will be sent to the message buffer. So again, messages will be sent to the message buffer. And finally, new messages will not be sent to the message buffer, so that is not B. So what we want to determine whether the system is consistent. That is, are there truth values for each of the propositions? So for L, Q, and B, so that all system specifications are true. Okay, so we need not B is true, thus B is false. Okay, so that's something we definitely need because this is a lone proposition. So we need that B is false. So now we can look at not Q implies B and not L implies B. And if the conclusion is false, in order for the implications to be true, then the hypotheses, not Q and not L, must be false. So what I just said is that we must have not Q is false and not L is false. So this means that Q is true and L is true. And because if the conclusions of these statements are false, we know true implies false makes an implication false. And so not Q and not L must both be false, which means Q and L are actually true. Okay, so if L is true, since not L is false, by implication, we automatically know that not L implies Q, implies Q is true. Okay, so let's double check. So far we have managed to get not B true, not L implies B true, not Q implies B true, and not L implies Q true. Similarly, by the biconditional, since not L is false, this means that N must also be false. Okay, but we can make N false, and hence we've been able to identify truth values that make all of these propositions true at the same time. So let's just summarize this. So therefore, if, let's review, B is false, well, maybe we can say, so B is false is here, Q is true, L is true, and N is false, right? And that's all of them, L, Q, N, and B. So B is false, Q is true, L is true, and N is false. Q is true, L is true, and N is false. These system specifications are consistent. And so this question is out of 5 marks. So by getting each of these, let's just make another thing. So by translating each of the system specifications into logic is 0.5 marks each. So this part is 2.5 marks. And then this piece where we're identifying the values with the explanations is each 0.5. Okay, for a total of 5 marks each.